Okay, so let's get started. Okay, now today I just wanted to write one more program. Okay, so based on that, I'll try to explain you the rules. So let's take one more class. Okay, and what I want to do with this program is, or with this class is nothing but just wanted to print the address of some person. Okay, for which what I'm doing, I'm trying to create a class. So for creating the class, what is that I have to do? I have to use a keyword called as class, and I need to give name for that class. So how to give name for that class is nothing but whatever you choose to give, you can give. So I'm just trying to say it as user address, as this class is trying to do, is trying to print address details of a user. Okay, so let's do it. So now if I want to print the details on address, so where do I need to write? So can I write anything directly inside the class? No, you cannot write directly inside the class. So what you can write directly inside the class and other statements where you can write, we will discuss it later. But for now, to write any instructions, we need a method. And the JVM will start executing from which method? From the main method, right? So let me declare the main method. So how to declare the main method? We need to use public static void main method, right? So which takes string arguments as a parameter. Okay, so this is what. So I have a user address class, which is having a main method for JVM to identify this main method and to start executing it from the main method. Now, what I want to do, I just want to print. Okay, I just want to print the address details of so and so person, some XYZ person. So, for printing something on the console in Java, what is the statement we need to use? We need to use the statement called system.out.println. Okay, and within the parenthesis, within the double quotes, you need to give what is the string that you wanted to print. Okay, so I just wanted to print something like this. So there is a user called Sachin. I just wanted to, I'm printing the name of the person. Okay, and I also want to print his house number. Okay, his city and his country, or otherwise his street and his country. Okay, so for which what I'm doing, I'm writing one more sys out there. One more print statement. What is it? System.out.println of, let me say, house number is some 12 dash some 7 dash 56 or something. Okay, so this is the house number, and I wanted to print his city. Okay, so I just wanted to print his city. So let me say Delhi. Okay, so this is what. Now we are able to write one more class where this class is doing what? This class is able to print address details of a so and so person. Okay, so once you are able to open your editor and you open a new editor, new page, and you just start writing a class by writing the main method. So once you write this, what you have to do? We just need to save this. Okay, we need to save this. So what I wanted to save this class as, let me save it as user address only. Okay, I'm saving this class name as user address dot java. Don't forget to give the extension. So this became a Java class now by giving the Java extension. Now what I want to do, so once I'm able to save this class, once I'm able to write and I'm able to save this class, what I need to do, I need to open the command prompt, which we call it as terminal. So terminal will always open where? In your default directories. In in Windows, it will open in C directory. In C directory, it will open in your user, whatever the current user with which you logged in. So that is the directory in which it will open. And Mac, it opens in the user directory who has logged in. Okay. Now, once you're there, what you have to do? You need to go to the directory where this file is saved. So where is my file is saved? It is saved in desktop. Right. I'm using the cd command, which is nothing but cds change directory. From that location to move to the directory called desktop, which is there in the current location. Okay, so I'm able to move to desktop to, sorry, to the desktop. Now from there, where I have to go, I need to go to a directory called core Java. Okay, so I'm able to go there. And from there, what I'm doing, I'm trying to check for day 3. There is a folder called day 3. Inside this, I have saved it. Okay, you can check here. So inside the day 3, I'm able to save a file called as user address.java. Now I am able to go to that location. Where I am right now, you can check where you are right now with a command called as pwd, present working directory. This is a Linux command or Mac command. It will not work in Windows. Okay, you can use dir, I think. So dir will just print the folders which are there. So there should be some other commands, or in Windows, anyhow, you'll be able to route it using the navigator, right? So you can look like that. So, but in Linux or some other mission, if you want to see where you are, you can use a command called as pwd, present working directory. Where I am, I'm inside my user. There's a desktop folder. Inside it, there's a core Java, and I'm able to get into day 3 where I have my program. So once you're there, what you have to do? You have to use a command called as Java C. What is this command? This command is used for the purpose of compiling your Java program. Okay, before executing your Java program, what is required? You need to do compilation. So how to do compilation? You need to use a command called as Java C. So before continuing, so all of you, did you install Java? So we have shared in YouTube link. So were you able to follow and were you able to install? Everyone, just say yes if you are able to install.
Yes.
Okay, if anyone is unable to
Install JDK.
which version you have installed? JDK 11? Hello.
It's 22, sir.
Okay, 32, no issues. You can install any version. Okay, so it should be at least 17. Try to install at least 17 or above, not below that. If you install below 17 also, it's fine. So we'll see how to install different JDKs in the future classes. You can install any number of JDK versions. That's not a problem. So there is a way we can set the version which we wanted to use. Okay, so there is a way we'll do it. Okay, for now, if you have installed any lower version also, don't mind. Okay, so there should be some JDK version that should be installed in your mission. If that is the case, it is fine. And if anyone failed to install or if you're having any issues, please reach us. We will be able to help you. All right. Now saying that, what is that I have to do? I need to compile it. So what is the file name I have to compile? This is nothing but user address.java. Right. I'm not typing. I'm using the tab button as I have only one class in that. When I use the tab, it will automatically completes the typo. Okay. Whatever I want to type here, if I'm able to use the first letter or whatever it is, it will try to type the word of the particular file completely. Okay, this is what I'm using. So you can type or you can use that particular tab option in your, even in Windows also, you can use the tab. So once you write it, if you see some file, if you want to auto complete it, just use the tab button, it will auto complete it. Okay, now let me compile this. So once I compile, so I should be able to see a dot class file that should be generated, right? I have a dot class file. Now what I should do, I just need to execute it. For executing a Java program, what is that I need? For compiling, I need Java C. For executing what I need? Java. It's nothing but JVM. So Java can also be called as JVM. So JVM is the person who will be executing the Java program. So which always expects what? Dot class as an input. But you should not give what? You should not give dot class to it. Okay, just exclude the dot class extension and just give only the name of the file. So the name of the file is what? User address. Once you click enter, it will just print whatever we have given as an input to that particular class. Okay, so we are able to see the output on the console. Uh, is this screen visible? I mean, the letters all are visible or they are very small, like if people are not able to see them. Based on that, I can increase the font and I can show you. Is it clear?
Clear, clear.
Okay, so if you have any issues, please let me know so that I'll increase the font, or otherwise I'll go with this font itself. Okay, so this is what. Okay, so with this, we are able to write one more program where this program, what it did, it tried printing the address details of a person. Okay, and the person name is Sachin, his details, it has printed. Now, let's talk about some rules that we need to follow while writing that particular program, while writing a Java program. What are the rules that we need to follow? It's nothing but okay, so in a Java program, we can write any number of statements. Okay, we can write. Okay, we can write any number of statements. So in which order they will get executed if you write any number of statements. So I have written how many statements here? Three statements, right? So I have written three statements. So once I have written these statements, in which order your program is going to be executed and how it is going to be executed. So it is going to execute. Okay, so which will execute one by one. Okay, line by line, which is one by one in sequence order. In which order? In sequence order. Okay, in sequential order means from here it starts one by one. Once it is able to execute this, it goes to the next line. Once this is completed, it goes to the next line. So from top to bottom, one by one, it goes in a sequential order. Okay, so and how many statements you can write? You can write any number of statements, but the execution always happens from the top, from first line to last line. So it goes one by one in a sequential order. So that's the first rule. So what is the second one? So secondly, so every statement in Java should be terminated by semicolon. If you see here, I have written three statements, and every statement is what? Every statement has ended with semicolon. Okay. So in Java, once you write a statement, every statement has to be ended or terminated by semicolon. Every statement in Java should be terminated by semicolon. Okay. This should be done. And what is the third rule? So now Java is called as what? Case sensitive language. Okay, Java is called case sensitive. Java is case sensitive. So it means what? It means the lower case, lower case, right? And lower case and uppercase are always different. Don't think they are same. Okay, now if I see here, if I see this S is capital here. All these are what? Small. Okay, if you see any of these things, I have written all of them as a small in lowercase. If you see in this string, I have used this S as a uppercase and remaining all are in smaller case. So if you see anywhere here, if I'm using anything in uppercase and if I'm using a smaller case, both are not same. Both are different. So your Java program is going to treat both the uppercase and lowercase as different characteristics, different statements, not as the same statement. Because Java is what? Java is case sensitive program, case sensitive language. Okay, and what is the fourth rule? If we don't write main method, okay, so in our class we have written the main method, right? If we don't write main method, okay, so we can compile the program successfully. So compilation of the program without the main method is going to happen successfully. So there won't be any issue. Like let me write one more class. Let me write one more class. Let's say class followed by a sample. Just I'm naming a sample. So I'm not writing anything here. Okay. I'm not writing anything here. Just I have created a class and I'm just saving it. Okay. Now let me come here to my terminal and let me say Java C and let me call sample.java. I think I have not given the extension here. Let me remove it. Let me give the extension to this, or otherwise it will not be treated as Java. Okay. So and so now this became a Java class. So let me say Java here. Okay. So now if I say enter, you can see a dot class that got generated. Okay. There is a dot class that got generated. So there is no issue if you write a class without a main method and you try to compile it, there won't be any issue in compiling it. Okay. But if you try to execute that particular class, now, how to execute it? We need to use a command called as Java and call the class name, just the class name without the extension. Click on enter. So it throws an error. It throws what? It throws an error or it throws an exception. So what is an exception and all those things? We'll see it later. But right now you can see there is some error which has thrown. So what it is saying? It is saying that main method not found in class sample. Please define main method as public static void main. with string arguments. Understood, right? So it is clearly giving you an exception, saying that you have not written a main method inside your sample class. So please write it in this way. Okay, so use this syntax and you have to write it. If you can write it this way only, then I'll be able to understand that is the main method and I'll be able to execute. So what is the third, what is the fourth rule? If you don't write, what is the fourth one? If we don't write main method, right? If you don't write main method, so then code is valid. So code is valid and it will compile. But what happens? It will compile successfully. It will compile successfully. But what happens? But at runtime means what? Runtime is nothing but when you're trying to execute it with the Java command. So at runtime, it will what? It will throw an exception. Okay, it will throw an exception. What is the exception it is going to throw? So we have seen it here, right? So what is the exception it is throwing? Please define main method as so and so. Right? It is going to throw this exception. All right. So the latest versions of Java, JVMs are throwing like this. Previously, you can see a different method. So some of the compilers may written a different error also. What it will written as no such method error. Okay, there will be few more compilers. So means compilers are coming, they will be coming from different vendors. So different vendors may try to display the error in different way, but still it is going to be the for the same purpose. The error is going to be displayed for the same purpose. Like if you are not providing a main method and if you're trying to run it, it is going to give the same error. Some of them are going to throw error like this and some of them are going to throw an error in different way. But they try to communicate with you saying that there is no method, no main method. So few of the compilers may write you what? No such method error. Followed by it will say what is that method that it is not able to find. It's nothing but main. Okay, so few of the compilers may written the exception like this. And what is the fifth rule? We can also write an empty Java program. What? We can also write an empty Java program. Okay, so it is possible to write a empty Java program. Okay, so let's write a empty Java program. So what I will do, I'll just create a file and I'm not writing anything here. I'm just trying to save this file, save this program with some name. Let me say sample one. Okay, I'm just saying it as sample one. So, and I'm just, okay, still I forgot to give the extension. No problem. I can go and I can do it here. Let me give the extension as dot Java. Okay, so I can have a program. I can have a program. So these are all called as programs. Inside the programs, what we have? We have classes. Inside the programs, what we'll do? We'll have classes. Inside a program, we can write any number of classes. As we spoken previously, inside a program, we can write any number of classes. Okay. So now what we tried doing here, we tried writing a program name is sample, and we have not written any class here. So is it allowed? Is it allowed? Once again. One second. Mhm. Just give me a minute. I need to save this. I need to save this also. Let me do one thing. Let me open the file from the location. So this is the file. Okay, so if you see here in this class, I don't have any class. Just I have name. I have saved the program name. That's it. I have not written any class. Now come here to the compiler. Okay, sorry, to the console. Go to the console and save Java C followed by sample one dot Java. So if I say run, so it is able to compile. It is able to compile and it is able to what? It is able to even generate a. So is it able to generate any dot class file here? So it is not able to generate any dot class file here. It has just compiled it. As there are no classes inside that program, it has not generated any dot class file. See here in this location, we are not able to see any dot class file for what? For sample one. There is only a Java file. We don't see any dot class file. Why we are not able to see any dot class files? Because I haven't defined or I haven't created any classes in this. So what is valid? You can have a Java program without any classes. Okay. So that's the fifth rule. Okay. So that's about the fifth one. Now, what is the sixth one? So we can write any number of classes in single Java program. Okay, and Java compiler will generate dot class file for every class that is available as part of that particular program. Okay, what is that? We can write any number of classes inside the Java program. Okay, so what happens? Java compiler will generate dot class files. It can generate dot class file for every class. For every class available in the program, in the Java program, right? So now let's try. See, in this, I haven't written any classes, right? Let me write a class followed by, I'm saying uh, sample two, or let me say sample one. Let me not give it sample one. What should I give? Let me say add. Okay, so I have written one class here, and I'm trying to write one more class. Let me say subtraction. Okay, and let me write one more class called division. Okay, so I can write any number of classes. For now, I have written how many classes here? I have written 3 classes. And let me save this class. Let me say Control S, Command S. So now these classes are saved in the program called as sample one. So now what happens if I try to compile this class? Open your terminal and say Java C followed by Java C followed by sample one dot Java. Now what happens? You should be seeing 3 classes that should be getting generated in the folder. Okay, wherever you see the Java file, inside that file, now you should see 3 classes that get generated. Okay, 3 dot class files will get generated with the names what? Add, sub, and div. Okay, right now if you see here, we don't have any those classes naming add, div, and sub, right? Now once I say enter here, after this, if everything is good, it will generate 3 classes. Now see here, there is an add class that got generated, there is a division class which is generated, and there is a subclass which is generated. Okay, so as I said, how many classes you can write inside a Java program? You can write any number of classes, right? You can write any number of classes inside the Java program. So Java compiler will generate dot class files for every class available in the Java program. Is it clear till here? Everyone, is it clear?
Okay, okay.
All right. So this is about the rules that you need to keep in mind. So there are so many other rules which will be coming. Okay. So while keep on going on in the future lectures, we will see so many other rules. For now, whatever we can be able to process and whatever we can remember, till that I have covered the rules. Okay. Remember these rules and try to write a Java program and the classes and try to compile it and execute it. Okay. Don't forget about the semicolon. Don't forget about giving case sensitive, try to maintain the case sensitiveness because case sensitive Java is a case sensitive program. So you should always be careful in in writing the lowercase and uppercase. All right. So, and if you want to execute it, don't forget to add the main method. Without the main method, if you try to execute the Java program, it is going to throw this particular error. Right. Now let's move on in understanding the JVM architecture. Okay. So the next topic that we need to understand is JVM architecture. So why do we need to understand this is nothing but you need because whenever we write classes, you should be in a imagination to identify like what and how the internally the JVM is trying to maintain the things. It makes your job it makes your job to understand the Java programs and execute them and to process them, right? So because of which understanding the JVM architecture is going to give you an additional view of understanding the programs in an easy manner. Okay, for which let's try to understand the JVM architecture. So now inside the JVM architecture, when we compile the Java program, generally what is that? When we compile the Java program, what happens? So first, your Java program, it will check whether the Java program or code is valid or not. Okay. So who is going to do this? Compiler. What is compiler is going to do? Compiler is going to check your Java program whether the program code is valid or invalid. So as I told you previously about all the 6 rules, based on the 6 rules, it will tell whether the class is valid or it is not valid. Okay, so if let's say if the program is valid, okay, then what happens? Compiler will generate dot class file, which contains what? Which contains a bytecode instructions. What it contains? It contains bytecode instructions. Okay, when we compile Java program, okay, first what it will do? First, it will check, it will check whether the Java program valid or not. Okay, so is it valid or not valid? So it will check that. Okay, and if program, if program is valid, what happens then? Then compiler will generate dot class file. It will generate what? It will generate dot class file. So what is this dot class file contains? What does this dot class file contains? It contains bytecode. Okay, it contains bytecode instructions. So what is this bytecode instructions and who will understand this bytecode instructions? We'll discuss about it. Okay. So bytecode instructions are the instructions which will be understood, which will be understandable by JVM, not by programmer. Program will not understand the bytecode instructions. Who will understand this? JVM will understand. So what is that we will be able to understand? We will understand the Java code. So this we can understand, right? If I write a class name, followed by if there are some sysout statements, all these things. These things we will be able to understand because it is like it is written in a simple English. It's like it is in the English language. So generally this is called as eye level language. So as we are writing the instructions and statements within the class using high level language, so that is easily understandable by programmer or any human being. Okay, so once this is compiled, it will generate what? Bytecode instructions. That we don't understand that. We will not understand the bytecode instructions, which is generated by Java compiler. Okay, who will understand that? It will be understood by your JVM. JVM understand those bytecode instructions and it will be able to execute those instructions. Okay, so bytecode instructions are special Java instructions. What are they? They're called as special Java instructions. Bytecode instructions are special Java instructions. Okay, so they are special Java instructions which are ready to convert into mission code. Okay, so which are ready to convert into mission code. So add to the last, who has to execute these instructions? Mission, right? Mission means nothing but your operating system. Means your operating system will internally talk to your microprocessor. So microprocessor is the person who has to execute these instructions, right? So who is going to do this? So your Java code is ready to convert into what? Mission code. So Java JVM will be able to convert this bytecode, the special instructions into mission code. So once it is able to convert that into a mission code, that will be understood by your mission and your mission will be able to execute the output. Okay, it will be able to execute the output. It will give you the output based on the execution. Okay, so now saying that, let's see the JVM architecture. The other day we tried drawing few of the elements, right? Now let's try to complete the complete elements of the JVM, what we have, and let's try to discuss about each and every component that is available as part of the JVM architecture. Okay, so give me a minute. Give me a minute. Okay. So once JVM is able to compiler is able to compile the Java program, what we have, we will be getting, sorry, you'll be getting a dot class file, right? So this dot class file will be what this dot class file will have? It will have byte code. What is this byte code? It is a special Java instructions. Okay, this dot class will have byte code, special instructions which will be understood by your JVM. So inside your JVM, there will be three sections. JVM will have three sections. The first section is class loader subsystem. Who is the first person here? Class loader subsystem. Let me write it. Class loader subsystem. Okay. So the first person we'll have as part of the JVM is class loader subsystem. Then the next component what we have is we have a memory area. Okay. Runtime data area or memory area. So inside this, what we have? We have five components. What are they? The first component is what? Method area. You people are able to see my screen, right?
Yeah, yes.
Okay. So the first component is method area, and we have the next component as a heap. Okay. The next component is heap. And later we have what? We have stack. Okay. And we have PC register. I'll discuss about all these components. Just give me a minute. And the last component in the memory area, we have native stack. Okay. And the third section. So this is the first section here we have, and this is the second section. This we call it as what? Memory area or data access area. Okay, we call them as memory area, data access area. Later, what we have? We have a runtime. Okay, runtime execution engine. We call it as what? We call this as execution engine. Inside this execution engine, we have two components. Okay, what we have? We have two components. What are they? One, we call it as interpreter, and the second one we have compiler. Okay, so we call this as what? Execution engine. We call this as execution engine. And we have two more other persons, which is a native interface. Okay, we have a native interface, and other one is native library. Okay, so class loader subsystem communicates with the memory area, vice versa. Okay, so this memory area and these two guys communicate with each other, and there will be communication between your execution engine and between these. Okay, so this is how they generally communicate, and this execution engine talks to whom? It will talk to the operating system. Okay, it talks to the operating system. So this is the complete JVM architecture. Okay, so they have what? We have three components. The first component is class loader subsystem, and next we have memory area. Within memory area, we have five blocks. Okay, five components. What are they? Method area, heap, stack, PC register, and native stack. And we have what? Under that, we have an execution engine. So your execution engine contains two people. What are they? Interpreter, and other one is compiler. And we have a native interface and we have a native library. So always your execution engine talks to whom? It will talk to it will communicate with the operating system and vice versa. Okay, so this is how generally the JVM architecture looks like. Okay, so let's say this is the third component we have here. Now let's discuss about each component. Okay, let's discuss about each component what we have in this particular JVM architecture. Okay, so I'll share you this particular diagram afterwards. If you want, you can note it down. If you want to note it down, you can note it down. Otherwise, I will send you this document. Do you want to know or you want me to send this?
Send, sir.
Okay, I'll send this then. Okay. Okay. Now let me disconnect this. Okay, now let's discuss about each component here. Okay. So the first component what we have? We have class loader subsystem. I know a few of the components I have covered in the previous class. I just wanted to repeat so that it will be again, it will be a good thing like we'll be able to recollect and we'll be able to remember them easily. Okay, let me recollect all those components what I have discussed in previous class. So with the first component, what we have class loader subsystem. So what is the purpose of this class loader system and who is this person? So class loader subsystem is the first program available in JVM. What is it? First program. It is the first program available in the JVM. Okay. So this is responsible for, and this is responsible for what? It is responsible for loading dot class files into JVM. What it is? It is responsible for loading dot class files. Okay, as I told you, dot class files. So where are my dot class files saved right now? They are there in my physical directory, right? On my hard disk. So now JVM, when I initiate the JVM, where JVM will be initiated on my RAM. You know, right? RAM is called as RAM. There will be two memories inside your computer. What is there? What are they? Primary and secondary, right? So we have what? We have RAM, we have an hard disk. So whenever you save files permanently, they will be saved on what? In your physical drive, which is nothing but your hard drive. So whenever you try to run something, where that is going to run? On your RAM. Okay, if a computer wants to execute something, first it has to load that particular files onto the RAM from your hardware. Sorry, from your hard disk. From your hard disk, it should load those files onto the RAM and then it has to execute it on the RAM. And once that is done, it will be closing those files and they will be permanently saved on the hard disk again. So your hard disk is maintained for storing the files permanently, whereas your RAM just it is used for the purpose of say executing the programs at the runtime. Okay. Now, as I said, what is it your class loader is doing? It will come to this physical directory and it will try to load the file into the JVM. So on top of your RAM, when you call a JVM, JVM is going to occupy certain space on the RAM. You'll have RAM of some size, right? 3 GB, 4 GB, 5 GB, 16 GB, something like that, right? So what it does, your JVM will try to, whenever you call the JVM immediately on top of the RAM, it will try to occupy some space. Okay, and what it will do, it will call the first program class loader, and it asks the class loader to go to the physical directory and get the file and load it to the JVM. This is the first instruction that will be given by the class loader. Okay, so it will try to load the dot class files. Okay, so into JVM. Now what happens once it is able to load the files, dot class files? Okay, so it will try to load them into what? Into JVM. And what it will do? So it will check whether the dot class file is containing valid bytecode or not. Okay, so how it will check this? By using a program called verifier, bytecode verifier. Okay, so what it will do now, once it is able to load the file onto the JVM, so the next thing what it will do, it will check. It will check whether the bytecode is valid or not. So with whom it will do this? By using a program. By using a program called what? Bytecode verifier. Okay. So using this program, bytecode verifier, it will check whether the bytecode that is generated is valid or not. So that's the first thing what your class loader subsystem is going to do. The first component of your JVM is going to do this. Now what we have next? We have runtime data areas, right? We have memory areas. The second thing. So inside the memory areas, what we have? So what is this memory area, sir? So once the bytecode is valid, then class loader subsystem will do what? It will take the dot class file, okay, and it will try to split those components inside the class loader, your dot class file, into different memory locations. Okay, so your subsystem, class loader subsystem is going to take the components of your class, whatever your class is given to the JVM. From that class, it takes components and it is going to save them, or it is going to store them in the different components that are there as part of the runtime data areas. So we have memory area, right? In memory area, what components we have? We have 5 components. Inside those components, it will try to save them. Okay, it will try to split according to which one will fit in which memory block. Okay, so let's see this. So inside method area, what will be there? What will be saved? So inside the method area, what we'll have is nothing but inside the method area, class code and method code. What will be there? So we have the class code and we have method code, right? Inside the class. You see here in this, we have a class and we have a method. So where this will be stored? So this class code and method code is going to be stored in which memory location? Inside the method area. Okay. And next we have what? We have heap. So inside heap, what will be there? So heap contains all the created objects. Okay. So it contains all created objects. So what are objects? We will see it. Okay. I'll show you when that particular topic comes. Okay. Whenever that scenario comes, I'll show you what is an object. But remember, what will be there in the heap? When you create an object, for what we will create an object? For class, we will create an object. Okay. So class is not a physical entity here. Class is just what? A blueprint. As I told you, there is no existence to it. So when you create an object, then the physical existence for that particular object is going, for that class is going to be available. Okay. So now when you create an object for a class, that the memory for that object will be available as part of what? As part of the heap memory area. So it contains all created objects. And we have what? Third, we have Java stack. We have what? We have Java stack. So what will happen within the Java stack? So it contains all the methods which are under execution. What it contains? Contains all the methods which are under execution. Okay, so which are all the methods that are under execution? All those methods are going to be available as part of Java stack. So we can also call as what? Java stack is a collection of different frames where each frame contains exactly one method. So what will be there in the Java stack? What will be there in the Java stack? A collection of different frames. Collection of different frames where each frame, each what? Each frame contains exactly one method. Okay. So your Java stack contains what? It will have all the methods that are under execution. What are all the methods that are there under execution? It maintains all of them inside the Java stack. And what will be happening here? It will maintain each method in one frame. So inside the stack, there will be frames. Inside stack, what will be there? There will be frames. So each frame contains what? Each frame contains one method. Okay, each frame contains one method. Like, let me tell you, like here, inside this method, inside this class, I have one method, right? Which is a main method. So I am writing one more method. Okay, I'm writing one more method here. Public, let me say public static void, let me say M1. Okay, I have this method. And I have one more method. Okay, let me say that is M2 method. Method 2. Let me copy and paste this here. Okay, and I have one more method, which is method 3. So what I'm doing here is from main method, I'm trying to call M1 method. So how to call a method? This is the way we have to call other methods inside one method. Okay, so what I'm doing, I'm calling M1 method. Inside the M1 method, what I'm doing, I'm trying to call M2 method. I'm trying to do what? I'm trying to call M2 method. And inside the M2 method, I'm trying to call M3 method. You see this, right? So in the main method, so in this class, I have written totally 4 methods. So methods are nothing but the blocks which contains the logic that has to be executed. Okay. In Java, we write the logic inside the class, inside the methods. So our statements or the logic, where we will write them inside the methods. In other programming languages like C and C++, we call them as functions. Functions are nothing but in Java, we call them as methods. Instead of calling them as functions, we call them as methods here in Java. Okay. So what is that? Functions are, sorry, methods are what? Methods are the pieces or the blocks which contains the actual logic in which the logic will get executed. Okay. Inside a class, you can write any number of methods. Right now, I have written how many methods? I have written by excluding main method, I have written 3 methods here. How many? M1, M2, M3. So main method is doing what? It is calling the M1 method, and M2, M1 is calling M2, and M2 is calling M3. So there is a sequence order of how these methods are getting called here. Now, what happens once you call like this? Okay, let's see what happens inside the stack. What happens inside the stack? Let's understand that. Give me a minute. Just give me a minute. Let me connect my device. Okay, so what happens now here? Nothing but, so sorry, your stack will look like this. Okay, so what is the first method? The first method that will be called by JVM is what? Main method. I told you, right? So always the first method that gets called is what? Main method. Now inside my main method, what is that it is calling? It is calling the M1 method. Okay, there will be one more frame. So you see this, right? This part. Like this, it will open frame for each method. Okay, now my main method is calling M1 method. That's the reason there will be a frame that will be opened for M1 method. Now, as my M1 method is calling what? Another method. Which method? M2. So there will be one more frame which will be opened up inside the stack. What is this? This is Java stack. Okay, now my M2 is calling what? M3. There will be one more method that will be called by M2, and there will be a frame which will be open, and your M3 method is going to be available as part of the stack. Okay, now once these methods are called like this, the execution inside the stack, how it happens is nothing but last in, first out. Whichever as came last, that will be executed first, and it will be terminated out first. It will be coming out of the stack first. Okay, whoever has entered into the stack first, he will be the first and he will be the person who will be executed first, and then the next people will be executed. Now in this case, first my main method came, right? My main method execution, in between it has stopped and it has called the M1. So from my M1 it has stopped completing the program, it called the M2. M2 stopped and it called the M3. Now, who is the last person who has entered? M3. So, whatever is there in the M3, let's say in M3, I have 3 statements. If these statements are completed, it will remove this from the frame and the call again goes back to M2. So, whatever is there in M2, it will execute that, and again it will remove this frame and it goes to M1. Whatever is there in M1, it executes, it removes this frame and it goes to main method. And inside the method, whatever is there, it executes and even terminates this. Got it? So this is how the execution of methods inside the Java stack are going to happen. Okay, so Java stack is what mainly? Java stack is the component or the memory area where your methods are going to be stored. Okay, and each method is stored what? Inside a frame, and the execution happens from what? Last in, first out. Okay, is it clear? It's clear, right, till here? Is it clear, everyone, till here? Or is there any confusion? Am I clear till here? Someone respond to me saying I saw something. You people are with me?
Yeah, yeah.
Okay. just try to respond because I don't understand otherwise. Like I'm just trying to talk, or if anyone is there or not, if I'm not able to understand, I cannot go forward. That's the reason. Just keep responding in between. All right. So that's about Java stack. You understood, right? Java stack contains what? All the methods which are under execution, and each method will be maintained as part of a frame. Okay. So the execution order happens in what? Last in, first out. Now, after that, what we have? We have PC register. What we have? We have other memory area called PC register. As I told you, what is PC register? PC register contains address of next instruction to be executed. What is it? PC register contains address of what? Address of the next line, next instruction. I mean to say next instruction to be executed. Okay, so this is what PC register does. It maintains the address, contains the address of the next instruction to be executed. Okay, so the value of PC register will be incremented automatically. You don't need to increment it. It will automatically increment the number. Okay. So that's it. PC register is what? So when it is executing the method, inside that method, there are different statements, right? Now each statement has to be executed. So each statement is what? An instruction. Now after, when your JVM is trying to execute that particular stack, so sorry, that particular method inside the stack, now it is trying to execute one instruction, right? The next instruction address is what? It will try to maintain this. PC register will maintain that, and it will give to the JVM. So JVM understands what? It will try to pick the next statement and it will try to execute inside the Java stack. Okay. Inside the Java stack where the frame is getting executed, inside that it takes that address and it will identify that particular instruction and it will execute it. Okay. So it just maintains the address of the next instruction that has to be executed. And after that, what we have? We have native stack, native Java stack. So what will be there as part of this Java native stack? Java native stack contains all the native methods that are under execution. Native means which are not part of Java, which are other languages. Okay. So if other language code has to be executed. So as I told you, so Java has taken its syntaxes and everything from C and C++. Okay. It is trying to bring few of the features from C and C++. So for which it thought that it don't wanted to implement certain libraries in Java as they are already developed in C. Instead of writing them again in Java, what it is trying to do, it is trying to call those native methods or native libraries inside this Java. Okay. Now, whenever we are trying to call those native methods, they need to get executed, right? Like how your methods are getting executed inside the Java stack. Similarly, when these methods are talking to the native methods, they also need to get executed. Now, where they have to get executed? They have to be executed inside the Java native stack. So what is going to be executed inside the Java native stack? So native, sorry. So it contains what? It contains, okay, native methods. Native methods are nothing but methods which are from other languages. Okay, so which are under execution. It contains native methods which are under execution. Native methods are nothing but methods coming from other programming languages like C and C++. Okay, and what we have, so we are able to complete what? We are able to complete method area. Sorry, memory area. So the first component is completed and second component is complete. What is the third component we have? Third component, we have native library, Java native interface, and we have execution engine. So let's talk about native library, native interface actually. First talk about native library. So we have what? Native library. What is native library? So native library. Now I have said, right. So there are certain methods which will get executed inside the Java native stack, right? Now if Java native stack has to execute these methods means these methods has to be available as part of JVM somewhere, right? So JVM should be able to maintain these libraries, right? So where it will maintain these libraries, the libraries which are belonging to other languages, is nothing but it maintains as part of the native library. So native library, it is a collection of, okay, collection of all predefined, non-Java methods or native methods. Methods are native methods. We call them as non-Java methods or native methods. Okay, so it contains all the non-Java, all predefined non-Java methods or native methods, as I'm telling you. So, which are all the methods that are coming from non-Java, is nothing but C and C++ or other languages. They will be available as part of the native library. So, from this native library, who is going to pull those native methods into Java stack is nothing but your Java native interface. So, your execution engine talks to the native interface. A native interface, there is some method inside my stack, which is nothing but the method which is there, which is part of which is a Java method. It is trying to call a native method. Okay, can you please load that native method into the Java stack? So at that time, okay, your runtime, your execution engine talks to the native interface. Native interface, can you go to native library and this is the method? Can you give me that method such that I will be able to load that method to the Java stack and it will be executed. Once the execution is done, the program that is dependent on this native method will be executed in the stack. Okay, this is what happens. So in order to load the native method into native Java stack, so it will be available as of the Java library. It takes the help of native interface. Who is going to take the help of native interface? Your execution engine. Okay. So what will be there in what is the purpose of native interface? Native interface is responsible to load required native methods into Java native stack. Got it? So it will load required native methods, into Java native stack. Got it? So this is the responsibility of what? Java native interface. So loading requires what? Loading native methods into like Java native interface, right? So sorry, into Java native Java stack. What is required? We require the execution engine. So we have last part is what? We have the execution engine. Okay. So what is this execution engine? So execution is responsible for converting bytecode instructions into mission code instructions. Who is actually responsible now? Now, what is JVM? What is Java? Java is a high-level programming language. Just give me 2 to 3 minutes. I'll close the session. Okay. So we are about to complete the execution engine. Once we are done, we can close the session. Just give me 2 to 3 minutes. That's it. All right. So execution engine. So as I told you, Java is what? Java is a high-level programming language. What is meant by high-level programming language? High-level programming language is the language which can be understood by the programmer. Okay, so but high-level programming language cannot be understood by whom? By your computer. Computer understands what? Only binary mission language, which is what? Which is zeros and ones. Computer cannot understand anything apart from mission language, which is zeros and ones. Now, JVM should be responsible for what? You have written your language, you have written your instructions in high level, right? So now that has to be converted into what? Mission language. So if the instructions what you have written as a developer, if they are converted into mission language, then only your machine will understand them and it will be able to execute those instructions. Am I right? Now, who is the person as part of JVM who is going to do this? Is nothing but your execution engine. So execution engine is responsible for converting bytecode instructions into mission code instructions. Okay, responsible for what? Responsible for converting bytecode instructions into mission code instructions. Okay. So who is responsible? Your execution engine. So this execution engine is having two components. Execution engine is having what? Two components. Java execution engine is having two components. Who are there? One is we have interpreter. One we have what? One we have interpreter, and the second component what we have is compiler. Why do we have these two? So basically in programming languages, what are the components which will be acting as translators? Who are translators? Translators are the people who will translate the language between to understandable people, right? So if I am trying, if people wants to communicate with each other and they don't know they don't know the language to communicate with each other. At the time, who will be coming to the picture? There will be one translator to whom these two people will be talking, and this guy will be converting that particular language into understandable language to each other. So, like that, so there are some translators which are available as part of programming languages, as part of computers. What are they? We have interpreter, we have compiler, and we have assembler. So the three people's duty is what? To translate the instructions from one language to other language. Okay, from high level to mission level. Mission. Okay. So this is the actual purpose of translators. So we have three types of translators. Who are the interpreter, compiler, and assembler. So Java, any one is sufficient for translating. But Java is maintaining what? Java is maintaining two. Why Java is maintaining two, and how these are going to helpful in translating and all, we'll see it in next class. But till here it is clear, right? So we have an execution engine. Execution engine is responsible for executing the instructions into mission code. Bytecode instructions will be converted into mission code. So who are the people who are responsible for doing this? We have interpreter and we have compiler who is going to translate those instructions, bytecode instructions into mission code instructions. Once it is able to convert those instructions into mission code instructions. So it will give those instructions. JVM will give those instructions to operating system. It will give to whom? Operating system. So operating system will take those instructions and it is going to talk to the microprocessor and it gets the job done by microprocessor and it takes the response and it gives back to the JVM and JVM will be displaying that output to us. Got it? So this is completely about your JVM architecture. Is it clear, guys?
Yeah.
Yeah. So whenever this is going to give you the bytecode instructions to the operating system, interpreter and compiler, once it is able to translate the code into mission, operating system will do what? It is responsible responsible for allocating required memory and CPU. You know CPU, right? So how much CPU it has to use and other resources. So all these things will be done by your operating system. So once it is able to give the mission code, it takes that and it allocates memory, required memory, it allocates the CPU. So there will be some percentage of CPU that has to be allocated to this particular program. It allocates the CPU and other resources. If this program requires any other resources, all will be allocated and yeah, mission code instructions are being executed by operating system and it is going to give back that result to the JVM. Okay. So this is what entirely happens with the JVM. Okay, let me quickly recollect all those things. Class loader is what? Responsible for loading the .class file from physical location to JVM. Method area is for storing the class code or method code. Heap stores all the objects that are created. Java stack is going to maintain all the methods inside, and each method will be maintained as part of a frame, and it gets executed inside the Java stack. PC register, it maintains the address of the next instruction that has to be executed. Java native stack is nothing but the place where your other language methods are going to be executed. And native library is the place where other language methods are going to be stored. So if it is stored, then only it will be moved and it will be executed. And who will be able to move this library methods into Java stack? Native interface will help it. Okay, native interface will help in moving the native methods into the Java stack. And what execution engine will do? Execution engine, it will try to convert the bytecode instructions into mission code. So, and there are two people inside this execution engine who will do this particular responsibility. What are the interpreter and compiler? Once they are able to convert that into mission language, it passes to the operating system. Operating system will be able to allocate the required memory and CPU and other resources such that the program will get executed. Okay, so that's about JVM architecture, guys. So we'll see remaining concepts tomorrow. Okay, till here, try to recollect whatever I have told. Try to just memorize the things, and if possible, you can go and you can look for these videos other places, or you can try to find some documentation here and there, and try to go through all these things. Okay, such that it will help you for future classes.
Please provide this class notes.
Yeah, as I'm able to write it in the, okay, I'll send this today. Okay, I'll send this. I'll send it now itself in the WhatsApp group. You can take this. All right, guys. You have any questions? If you have any questions, you can post me. You can ask me now, or you can post me in the WhatsApp group. I'll be able to answer you. Any questions?
To exit. Hello.
Yes, yes.
Yes, sir. Am I audible?
Yes, you are audible.
Actually, you are writing that code like hello world and something else. So system.out.print.ln.
Yes.
They say where we need to execute this all these things like in a file, or we have any other tool to execute.
Where to execute this? You can just take a notepad. Take a notepad. You have notepad, right?
Yes, yes.
Just take a notepad. So
Uh,
don't, if you are familiar with IDs, you know IDs, right? There is our IDs like Eclipse. I
Eclipse
don't.
I have, but
If you have Eclipse and if you are already familiar with Eclipse, you can start using Eclipse. But I don't know everyone are known to Eclipse because I assume few of you are coming from very, I mean, coming directly. You may not have any computer knowledge previously. So those people may not be understanding where to execute and they may not be understanding about IDE. So that's the reason what I'm doing is in the initial classes, I'm using just an editor. And this will
okay.
also help you to understand the background things, how they are working. So what I did here, basically what I did in this class, I'll just explain that. So about IDs, we'll see in the future classes. Now what I did is, I just took a notepad. So here I'm not taking a notepad, I am using a software called a Sublime Test. You can use a notepad. You have a notepad, right? Just click, try to take a new file in the notepad, okay? And after that, just write a class like this. Okay, you have to write class followed by class name with a parenthesis, and you just write a main method like this. And to print anything, you have to use this statement system.out.println. I'll send you one sample program. You can take it and you can look. You can take a reference of that, about that program, and you can write a program. Okay, just after that, save this program with the class name, or you can give any name to that file. Are you asking this, or you are referring to something
Yeah, yeah.
else?
This one only, but
Okay, I will send you this file. So we have written one sample file, right? So yesterday we have written some sample file,
this
right?
also they
Sorry, I'm unable to hear you. Your voice is.
execute, right?
Can you repeat again? I'm unable to hear you.
Yes, yes, sir.
Yeah, you can go ahead now.
No, no. I just asking that one only. So I have to use a file. Notepad. Right.
Yeah. So I
After
just,
installing the Java, right, sir?
yes, yes, yes. You can write a file, but to execute that particular program, you need a JVM installed, JDK installed. If you don't have JDK installed, you cannot execute it. But still, you can write a program. You can still write a Java program, but for executing and for compiling, you need a JDK installed. If JDK is not installed, you cannot execute this.
Okay.
So don't worry, I can help you with this. So let me know when you have some free time, when you are in front of the system, just ping me in the WhatsApp. So I will help you. You can just share me your screen. I'll be able to help you with how to write it and how to do all the rest of the things.
Yeah, sure, sure.
Okay, just try. If you are still unable to do it, okay, so just you can connect with me. I can take a separate session for you and I can be able to help you in that. Not just you, anyone, if you are stuck like that, you can take my help. You can have a separate session. I'll be able to connect with you and I can help you with that. All right, guys.
Okay, sir.
Any other questions?
No, no.
Okay. So if you any one of you if you have any questions, you can just ping me in the chat. Okay, I'll be able to answer you. I'll be able to help you, or even I'll be able to give you some references which using which we'll be able to look into it and we'll be able to solve your problems. All right. All right, guys. I'll catch you up tomorrow.
Okay, sir. Bye. Thank you.
Yeah. Thank you so much, guys.